Hey everyone, I'm Todd Previs. I'm a product manager on Google Cloud Platform, and I've spent my entire 13-year career working in visual effects software. I've always been driven by the desire to make tools to make people's work better. I've never quite considered myself to be an artist, so what drives me is helping other people succeed. And the fact that I've been able to join Google Cloud Platform through the acquisition of ZYNC in September is really exciting. That Google is so invested in this space, and now to be able to be standing here in front of you, seeing all these people, a lot of whom I've worked with and known for many, many years, talking about the solutions we're working towards to make your lives better, to make your work more efficient, and to really improve what you do is really exciting to me, and I'm just really happy to be here as part of Google right now. So as Bell touched on before, I mean, Google Cloud Platform is an incredible infrastructure, and it was really new for me as well when I joined Google to understand what we're capable of, what the scalability is, and what you can achieve. And the way I like to describe it is it's the same infrastructure that powers Google today. So it's the same infrastructure that handles billions of search queries on a daily basis. It's the same infrastructure that's hardened, that's protected by over 500 security professionals, whose whole goal is to prevent nation-state sponsored attacks from Google. When we air the interview on Christmas Day, you can imagine the concerns about what sort of hacking might go on. This is Google's bread and butter, securing your data, protecting your data. And it's the same infrastructure that handles countless hours of video every day that are uploaded, transcoded, and distributed worldwide to hundreds of millions of people via YouTube. So to be able to offer rendering solutions on top of this infrastructure is really exciting. I'm going to talk about what I believe as the scalability and the visions you can achieve from this. And certainly, as Bell addressed before, rendering is only one of the workloads we're tackling. And we're doing this by working with our own technology as well as collaborating with best of breed. One of the things that when I joined Google wanted to make very clear is that we are not going for a one-size-fits-all solution. In the media space, every studio has a different way of working, has a different pipeline, has different tools that they're used to working with. So we've spent a lot of time not only working on our own internal technology, but really outreaching to the best-of-breed technology providers out there. And you'll see some of them speaking later on today as to how they've been able to bring their solutions to Google Cloud Platform to allow us to achieve more and more offerings. As a rendering platform in particular, there are some amazing things that we can do with Google, such as the per-minute billing. Again, as Bell was mentioning, you're only paying for what you use. There's no 60-minute blocks. There's no building out of infrastructure when you don't need it. So especially for burst capacity, it's a fantastic tool. And along those lines, it's also designed to save you money the more hours you run. So we have this thing called sustained use discounts. Again, it doesn't require any sort of pre-purchase of allocated compute hours. Literally, the more you run a machine during the month, the less you pay. It just naturally gets cheaper, and that's how we feel it should be at Google. Huge capacity. You'll hear from Rodeo Effects, you'll hear from Atomic Fiction, how they've been able to scale to tens of thousands of cores, literally at the press of a button, without having to reserve these, having them available, and just paying for what you use. And you can spin these up very, very quickly. As you'll see in a ZYNC demo I'll give in a little bit, you're able to spin up I'm able to spin up 60 nodes in a matter of minutes, get the job up and running, and finish the job and spin it down when it's done. And then specific to some of the rendering challenges we're tackling, we have our turnkey solution, ZYNC Render, which I'll show you at the end, as well as these technology collaborations. So I really can't emphasize how important it is for us to build out an ecosystem working with companies like ThinkBox, with Avere, with Atomic Fiction and their Conductor.io rendering solution, to give you as many options as you need to most seamlessly and securely migrate your existing pipeline from an on-premise workload to Google Cloud Platform. So looking at rendering workloads, whether you're doing an NFS mount on a nearby data center or doing an asset sync to a remote data center, there are a lot of the same challenges, a lot of the same things you have to build. But what I really look at it as is a hierarchy of needs. They're sort of from the bottom up. At the baseline, you have to make sure you can get your assets to the cloud, right? And you also want to be smart about it. You don't want to mirror your entire file system. You want to be able to parse a scene for all its dependencies. You want to make sure you're only ever pushing up the assets that are needed. You want to make sure you have enough licenses. So what you need the value if you're spinning up 1,000 machines, you want to make sure you can spin up 1,000 concurrent licenses as well and only pay for those. And at the top of this pyramid, I really see pipeline integration. So yeah, I can get all of the data up there. I can intelligently parse a scene. I can get licenses. But what we're really striving for with our solutions on Google Cloud Platform is something that I keep saying fits within your workflow, makes it feel seamless. So to the artist or the TD, there's no going outside of the way they would normally work. There are no extra steps, and it just feels exactly like it's part of your local infrastructure. And the way I envision cloud rendering essentially is that you could have 10,000 machines running on Google Cloud Platform at a data center, but it should feel like it's in the room next door to you in terms of the responsiveness, in terms of the interactivity, and in terms of the integration. So one of the interesting things that I've come across in talking to a lot of studios and getting their feedback as to how they view rendering is the total cost of ownership. And for a lot of studios, it's simply along the lines of, well, yes, I've invested this much in a render farm. These are my capital expenses, and these are my ongoing operating expenses for like HVAC, licenses, power. What I think we can do with Google Cloud Platform, and we think we've seen done with quite a few of our customers so far, is also cut down on the render times, give you burst capacity to the fact where the sort of unknown, unmonitored cost of idle artist time, which a lot of studios don't take into account, is now really severely impacted. So traditionally, you're at a visual effects studio, you have somewhat of a limited capacity for a render farm. So at some point, you're paying a CG artist, whatever you're paying them, to sit around and wait for renders to come back while they're in the queue. Right? So what we can do with Google Cloud Platform is achieve that scalability where that added cost that maybe you're not factoring into what the daily operational expenses of a render farm are, we actually are mitigating those, and you're not having artists sitting around anymore waiting for renders to come back, but we can do this amazing parallel processing where jobs are coming back to you really, really quickly, and the artist efficiency, which might be 20 or 30 or 40% wasted time, is really maximized. So they're able to work all the time. As I was mentioning before, we're collaborating with what we feel are the leading partners, the leading technology providers in the visual effects animation software industry. With ZYNC Render, we are providing licenses from Chaos Group, The Foundry, and Solid Angle. But as I also mentioned before, we realize ZYNC is not a one-size-fits-all solution. It's great for small to medium shops, but we want to make sure we can work across as many pipelines as possible, handle as many workloads as possible. So from that, we are really excited to be working, again, with very industry-leading companies such as Avir, and their virtual filer is now available on Google Cloud Platform. Atomic Fiction, which for a long time was actually a ZYNC customer, has built their own fantastic cloud rendering platform called Conductor.io on Google Cloud Platform, and you'll hear about them as well later on today. And ThinkBox Software, probably the leading render manager with their Deadline solution, has also now seamlessly extended their platform onto Google Cloud Platform, and you'll be hearing from them as well. So just to reiterate, the way I see this is it's all about all the technology collaborations we can do and how we can bring all these people to Google Cloud Platform to migrate your workload. Avir in particular, I want to call out, as we just announced this at NAB, and this is really designed for large studios. Studios that are using Avir locally to cache their data can now seamlessly migrate and sync that to Google Cloud Platform. So going back to the idea of a hybrid environment, if you have studios in multiple locations with multiple Avirs, all of that now can be seamlessly passed back and forth. And we are focused on bringing this hybrid environment to studios. We understand large studios have a lot of on-premise hardware they've invested in over time. But rather than buy more hardware or rent hardware for burst capacity, you can now literally extend at the push of a button to tens of thousands of cores and sync all of your hot data from your local Avir caches to our Google Cloud Platform Avir cache, which is really, really exciting. And you'll be hearing from them as well. Some of the early customer successes we've had, again, Atomic Fiction, a pioneer in visual effects rendering on the cloud. They've been doing it for a while. They'll tell you about some of the great things they're working on. Rodeo Effects, you'll be hearing from Jordan Souls, their CTO and executive producer, later on today about how they've been able to integrate Google Cloud Platform and Burst. Industriamantic, a smaller studio you might not know about. They're in Sweden, an architectural design visualization firm. But again, being able to seamlessly integrate their pipeline into Google Cloud Platform, showing the breadth of solutions we're able to offer from small studios all the way up to the really large ones, such as Framestore, who did a blog post in the fall about how they were able to use Google Cloud Platform to burst up to 15,000 cores for a very short time. So the alternative is literally for them spending $300,000 on new hardware for this very short burst capacity that really doesn't make a lot of financial sense and is a lot of work to get up and running. And with Google Cloud Platform, they're actually able to build their VM image within a day, get it up and running, deploy it, and start rendering tests the next day. I do want to take a little bit of time to talk to you about ZYNC specifically. It's very near and dear to me, and it's a part of Google. So I wanted to spend a little bit more time talking about Google's own cloud rendering solution, in addition to all of these great technology collaborations we have. So ZYNC itself is built from the ground up as a cloud rendering solution. It was started in 2010 at a very small visual effects studio called Zero Visual Effects in Boston. The founder came from a long career at Digital Domain. I think actually worked across the street, if not in one of these buildings, for about 10 years, and wanted to build an artist-friendly solution, something that obfuscated cloud. So for the artists, they didn't have to worry about setting up filers or getting licenses or command line syncing any of their assets, but literally a front-end UI that would be easy to use and fit into their existing pipeline. So the origins of ZYNC and the genesis of ZYNC has always been from a professional visual effects background. We like to say it's by artists for artists. We understand how people work. We understand how they want to work. And we have done our best to integrate our solution into that existing pipeline to make it as easy as possible to use cloud, going back to the idea of having a local render farm in your back, which is actually thousands of miles away in a data center. Had a lot of great success with feature films that have been rendered on ZYNC. Beyond that, again, looking at small to medium studios, over 12 million core hours in total, hundreds of commercials. In fact, the Moonbot Studios in Shreveport, Louisiana just won 2 Emmys for their short film Silent. It was done for Dolby Labs last year. They rendered the entire thing on ZYNC about 9 months ago. And a classic example of a small studio that had a lot of creative talent, didn't necessarily want to go out and spend the money or could afford to spend the money on a large render farm for this 4K project. It was the first 4K project they'd been given for this 3-minute short animated film. But we're really able to focus on the creative by using ZYNC as an integrated solution that fit within their pipeline, let the artists do their work, and submit the renders from Maya as they needed. Our workflow is, and I'll show you in a moment, is really all focused about intelligent asset management and file management. I think in our industry, we all realize we create a lot of data. We're moving a lot of data between different locations. And it's no different with cloud. You have to push data up at some point. So the way we've designed ZYNC is to actually analyze a scene for all of the assets, all of the dependencies, and upload those ahead of time in the background. So being able to manage your pipeline, being smart about pushing all of the assets up to the cloud so they're there, and at render time itself, when you go to submit a job, the only thing that's going to go up is a scene file. We also keep a copy of anything you render on ZYNC on the cloud. So if you're pushing those CG renders into comp and you're compositing in Nuke, and again, I'll show you this, and then you go ahead and launch a Nuke job, there's no file I/O to be done. Everything has been rendered on the cloud. It stays on the cloud. So we've tried to design a system that minimizes the bottlenecks of file I/O as it stands in our industry, and I think we've done a pretty good job with it. So with that, I'm going to actually take a few minutes to just give you a walkthrough of ZYNC here running on Google Cloud Platform and show you the reality of things. So ZYNC is now in a beta phase, and I've got a Maya scene here. So all of you have seen Maya. So this is just a 60-frame sequence here. This police car actually has about 500 different textures. There's HDR material, there's dependencies. So there are a lot of assets to manage. And as I mentioned at the beginning of my talk, you don't want to mirror your entire file system. You want to be intelligent about actually parsing only the data you need. So what we were able to do with ZYNC is actually parse a scene file for all of that data and upload it ahead of time. So I want to go ahead and launch the ZYNC shelf, the ZYNC plugin rather, from the ZYNC shelf in Maya. So we have a plugin inside of Maya. And once I launch this, you can actually see our dialog box. So the way we manage file I/O is to run this upload-only job. So when I click on this, everything is grayed out. I would go ahead and put my username and password in and submit the job. So at that point, ZYNC is going to do a scene analysis, again, pull all my dependencies, all of my assets, and upload those in the background. So by the time it actually comes to render a job, everything is up there. So I've already done this. So for the purposes of the demo, I just want to very quickly run a job and walk you through the user interface and what the workflow is like. So you can see here, I've got the number of machines I can choose to render, and these are the Google Cloud Platform machines. So you don't have to go out and build any sort of VMs. You don't have to configure any sort of command line render management. And this is a 60-frame sequence, right? So ZYNC has analyzed all of the data necessary from my scene. It's a 60-frame sequence, so I just want to use 60 machines. This idea of burstability, of scalability, of being able to turn jobs around faster so your artists are not sitting on idle at all is something that's really important to us and something we're working very hard to deliver. So machine types, I've got several different machine types, and these are based on the standard Google Cloud Platform machines. I'm going to use the 32 core machines. And you can see that's priced at $2.08 an hour, and my total cost is $124.80. But that's for the hour, right? And we bill by the minute. So if you were to render this and it's taking 11 minutes in total, you'd only pay that percentage of the entire estimated cost for the hour. So I think having hourly billing per minute billing is really critical in the rendering workspace. You're not wasting any time. I'll go ahead and set my project. It's already parsed my Maya scene from my output directory, from my project folder. It knows I'm using V-Ray, so for the renders we support V-Ray and Arnold right now. For V-Ray we support nightlies and distributed rendering. I'll just set the chunk size to 1, so I'll have every machine working on a frame. It's going to give me all the different camera options. I'll choose my beauty layer and put in my username and password. And submit the job. So ZYNC is then going to go through, do a pass, analyze the scene, and actually upload the scene to Google Cloud Platform and start rendering. So we'll just give this a minute here. It's going to go through everything here, generate that output pass, and upload it. And so imagine you have an artist now and they have 20 shots to work on, and you have a render queue that's backed up. I mean, you'd essentially be waiting for the one shot at a time to submit them. But if you have an artist who's got 20 shots lined up and you're using Google Cloud Platform and using ZYNC, you can just submit those jobs one after another. There is no queue. Just do one machine in parallel per frame. So the job's been submitted to ZYNC. I can go ahead and move to my web render manager. So this is something we built from the ground up. It looks like many of the render queue managers out there. Again, we tried to design this with the idea that people are using existing software tools. They want something that fits in their pipeline. They want something that's easily integrated. And in a few minutes, the job is going to start up, and we'll see all 60 of those VMs on Google Cloud Platform with V-Ray licenses spinning up and rendering the job. I think one other important thing to note is that this is not only a GUI-based application, but we also have full Python scripting. All of our plugins are open source. They're available on GitHub, so we've had studios, in fact, some of whom are here, have done their own command line scripting if it's integrating it into their asset management system, into their render manager, to do more advanced types of render control management. So we're trying to accommodate as many different workflows as possible and as many different pipelines as possible within ZYNC. Again, going from the fact that we come from a visual effects background, we understand how artists work. So this job is now spinning up here. In a minute, we'll start to see all of my machines, but you can see I've got all of my frames queued up here. I'll see all 60 frames. They're all queued up, ready to go. You can see my output directory, my frame range, my render output. So this is essentially my output directory here. This is my beauty pass, right? So this is empty right now. But as this job finishes, those EXR frames are going to come back one at a time. So you're not waiting for an entire job to finish. You're only waiting as long as it takes for each chunk to go. And in this case, I've set the chunk to 1. So very quickly, we'll start to see those frames spin up, render, and come right back down to my local output directory. So as an artist, you don't have to think about anything. You submit the job renders, it comes right back down to where you expected. There's no fetching of files, and it's designed as a seamless integration. So we've got all these machines now spinning up. You can see I spoke at the beginning about VMs spinning up very, very quickly on Google Cloud Platform. This is no exception. I've already got 34 of the 60 machines I requested up and running in a matter of minutes. So we'll soon see all 60 of those machines come online. We'll see everything rendering, and we'll see the final output. So while this actually starts up, there are a few more things I want to show you behind the scenes that we built within ZYNC to give you pipeline integration. So I have a My Account page here. And from this is all the administrative stuff, all of the custom scripts, all of the shaders, anything you would want to add within this workflow is available through ZYNC. So we have the admin account tab at the beginning, and this is where you can set your username, your password, your email. If you're a non-admin, this is the only thing you'll see. So if you're just an artist using the system, this is the only access you'll have. But then we've also got some advanced configuration controls. So you can configure things like the max number of running jobs, your custom gizmos for Nuke if you have custom shaders for Maya. We support all of that. Drive mapping, so let's say not all of your assets are living on a single NFS. You have assets living on different machines. You're able to set up drive mapping to make sure you can access all of those assets. You're also able to monitor your usage on a monthly, daily, weekly basis by host application, by job. So all of the billing you get is done through the Google Cloud Platform billing console, and you actually get a breakdown for every job ID and how much you spent on every one. So I can say, yes, I've rendered 45 hours of the 16-core V-Ray for this job for Nissan, or 300 hours at $2 an hour for this of Arnold for this job for Nike. So it's very intuitive in terms of being able to take those spends on rendering and actually quantify to the client, yes, this is how much it costs you. These are the iterations you want. This is actually how much you paid for it down to the minute. And I should note that all of our billing is done totally inclusive. So as I showed you back in the Maya plugin here, when I launched a job, this price you can see on the 32 cores, $2.08 an hour. That's inclusive for V-Ray as well. I mean, that's not a separate breakout of compute. Then you have to pay for ZYNC infrastructure or anything like that, or V-Ray. It's all bundled, trying to make this as easy and as friendly as possible. A few more tabs here. You can add users, projects. So all of the data you render on ZYNC is stored on ZYNC, and I'll show you a nice example of that in a moment. But you also have full access to all of your data. You can delete that at any time. Typically, storage is cheap. You're not paying much on your bill. It's 20 cents a gig a month, and that ends up being maybe 5% of a user's bill versus the total compute. But you're able to see all of the usage on a per project basis, and you can delete that at any time. So typically after a job is done, and perhaps you want to archive it off to our nearline storage, or you do an LTO, you're able to go ahead and delete those projects whenever you want. And one last thing to mention is we've mirrored the entire file structure of the files that have been uploaded from your local environment onto Google Cloud Platform. So if I were to look at my demo project here, just very quickly, you can see I've got all of my scenes, all of my source images, all the data that goes into making this Maya scene. So when I go up to the cloud, to Google Cloud Platform, and I'm looking at the storage we built for you of a filer on top of Google Cloud Platform, I can go through here and I can actually see a mirror of what my local directory structure is. So everything is meant to be as intuitive as possible, as simplistic as possible. So I can go back into my demo folder, I can see all my Maya scenes, I can see all the assets, and I'll be able to actually parse all of the data. So you can see scenes, images, source images. So you're able to actually see all of the data that's needed for the render that's been uploaded to Google Cloud Platform, to ZYNC. So when I go back to my main page here, we've actually got the job up and running, and you can already see the first few frames are going to be done in a moment. So this first frame is at 99%, and it's going to switch from downloading it'll go from rendering to downloading to done. And I'm just going to leave my file directory open, so you'll see those EXR frames come in one at a time. But within this, we've also done the same thing with our log files. You're able to go ahead and view all of your V-Ray logs or your Arnold logs or your Nuke logs. Everything's been repathed from a cloud environment to local. So everything you're seeing, again, with the feel of a local render farm. There's nothing cloud that you have to worry about pathing differently or anything like that. So this first frame is now downloading. You can see it's 100% done, and it's popping right back into my local output directory. So I can actually see the output of that very quickly without having to spend a lot of time waiting for the whole job to finish. Few other things to mention, just very briefly here, that you have all the standard render manager controls you have in a job. You can stop a job, you can restart a job, you can pause a job, cancel a job, you can add more machines to it by changing the job options. ZYNC's already rendered this job before, so it knows how long the job should take, and it's giving me an approximation of how much of the job is done. You can already see it's 48% of the way done, and that'll continue to populate. And on a per task basis, if you ever want to take a single VM and control or add controls to that, you can click on it, and then you've got all these task controls. So I can requeue the task, skip the task, and so on and so forth. So having this integrated solution is really, really important for us. So you can see these first few frames are done. I'm not going to wait for the whole job to finish, but again, I've got my EXRs coming down one at a time, and that idea of scalability, parallel scalability. I don't have to have an artist submitting a job to a limited farm and waiting for that job and waiting for the jobs queued behind it to finish. I spin up one VM per frame, the job gets done as quickly as possible, and I'm back and I'm working with it. So my EXRs are coming in, and I essentially want to move to the next stage in the pipeline, to compositing. So as you can see here, all those frames are coming back down locally. We're also keeping a copy on cloud storage. So when I go into Nuke, I have a background plate here. This is actually rendered on ZYNC. But I have my police car that I just finished, and it's also been rendered on ZYNC. But I have the loaded up the local EXR. Just did a very quick A over B comp, a little bit of motion blur, a little bit of glow. Save that project, and I can essentially just repeat the same process. So now when I go to render on ZYNC here, the plugin is going to launch, and you can see I have this upload only checkbox. So this is what you want to do with live action footage. You get the plates at the beginning of a show, just bring in all your plates into a dummy comp, run upload only, submit the job. But in this case, I know this CG was just rendered on ZYNC, and ZYNC knows it. ZYNC's going to make sure that all the assets needed are already there. In this case, that's the case, so I can just choose a 16-core machine. I'll just submit, just use one machine, put my username and password in, submit the job, and it's just essentially a rinse and repeat process. So that job is submitted to ZYNC, the nuke script is going up. ZYNC will make sure all the assets needed for the render are up there, but of course, our CG was already rendered on ZYNC, so there's no unnecessary file I/O, and essentially that's the workflow. So again, I'm not going to make you sit through the entire render, but just I can go ahead and very quickly bring up my final output, which will just come back to my output directory as soon as it's done, and play that back for you. And there you have it. So that's the ZYNC workflow for you. Try to make it as integrated as possible, working within host applications. And again, it'll be very exciting today to hear the other rendering solutions. I know Atomic Fiction has done great work with Conductor.io, ThinkBox, Deadline, many of you use that, and the Avira folks as well. So we're really going for the gamut of solutions here, and you're going to be hearing about all of them coming up this afternoon. So thank you.